We have with us today our OpenDDS team, and it is my pleasure to introduce the product lead for OpenDDS, who is also a partner here at Object Computing, Adam Mitz.
Thank you very much, Nikki, and welcome everyone. Thanks for participating in our webinar today or watching the recording of this later. So I want to start by giving a very broad picture of our company, Object Computing. And so a lot of what we do can be considered this sort of software solutions engineering services, whether that's in architecture or engineering or support in any number of different domains and with different technologies and expertise. So just wanted to kind of start out with that very high level view of who we are and what we do. And as you see over on the right, a lot of that has to do with OpenDDS, though certainly not all of it. So to set the stage for what we'll be talking about in depth today with Xtypes, let's talk about OpenDDS in general first. So OpenDDS is the secure and scalable connectivity framework that's connecting and powering next generation systems. So, what does that mean from a software project point of view, right? OpenDDS is a standards-based publish, subscribe solution. And as you see there, OpenDDS is an open source and widely adopted real-time publish, subscribe solution for distributed systems. So where does it come from, right? The ideas and the concepts of DDS come from the DDS specifications that are managed by the object management group. So all of those things are, widely adopted industry standards through the consortium. And our company, OCI, Object Computing, has implemented those in the OpenDDS project. So a completely open source DDS implementation along with a company providing the commercial support for it. And as far as I know, the longest running continually supported open source DDS project. So let's look at some general terms and concepts around DDS systems. So you see here a picture of a DDS network, and we often call that the domain. So what does it do? Well, the application needs to share data around many different participants, and it can organize that data into different topics. So we think of those topics as kind of ways to coordinate the sources of data into the network, which we'll call data writers, with the receivers of that data, which we'll call data readers. So you see here that each writer and reader has a particular topic that it's on. And we think of those writers and readers as caches. And so the application code can populate a writer cache with data, and it gets synchronized over the network according to quality of service policies to all of its matched readers that also have their own caches that have their own quality of service policies. And that data makes its way up to the applications. There's a lot of other concepts in DDS, but those are the key ones for what we're talking about today. So features of OpenDDS as a software project, so the complete DDS API, support for all the quality service policies, content filtering, multi-topic, and that support provided to both C++ and Java applications. Of course, we generate code from the IDL, and we'll talk a lot more in this presentation about the details of that. And OpenDDS supports that in C++, two different modes. We think of as classic C++ and the newer C++, as well as Java code generation. OpenDDS is a cross-platform project, so it works with common development tools and systems, whether you're targeting desktop, mobile, embedded, or cloud. And OpenDDS's architecture supports pluggable transport and discovery. So transport means how does the data actually make it into the onto the network and to the remote systems. Discovery, how does the domain sort of bootstrap itself and know where the peers are on the network and what they're doing. OpenDDS features support for the interoperable wire protocol, DDSI RTPS, so it can interoperate with other DDS systems that also support this standard from the Object Management Group. OpenDDS supports DDS security, so these interactions on the network can be encrypted, and the authentication and access controls that go along with that are provided. OpenDDS provides features for running the RTPS protocol over the internet, including these 3 features listed here: the RTPS relay and support for the IETF, STUN, and ICE protocols. And starting now, OpenDDS supports DDS Xtypes, and that will be our focus for the rest of this webinar. So I'd like to turn it over to my colleague Mike Kuznetsov to bring us into this first Xtypes section, introducing Xtypes.
Thank you, Adam. So why Xtypes? What is missing from DDS? What kind of system design scenarios can Xtype help with? The problem Xtype solves is rooted in the connection between the topic and its data format, which without Xtypes has to be resolved at compile time. Without Xtypes, any changes to the data format force modification to the existing topic or an introduction of a new one and require rebuild of all participants. There are at least 2 scenarios, 2 distinct scenarios when Xtypes offers solution to this problem. The first scenario is a distributed system evolution. As new participants are added to the system, their data format may deviate from the initial design. With Xtypes, existing participants are aware of possible variances in the data format and handle addition of new format participants without software upgrades. The second scenario is when the system design requires DDS participants a data format differentiation, but also communication on the same topic. One example would be a typical battery lab test unit, which collects data from a variety of sources like multimeter, temperature chamber, external charger, etc. Some units would not be equipped with a temperature chamber. Some other units may use optional instruments like AC impedance meters. So the data format from each test unit is potentially different, but the centralized lab control station has to receive and process them under the same topic. So this cannot be done without Xtypes. Let's go back to the system evolution scenario. A use case for it may be a car rental company. It already has a fleet of internal combustion engine cars and now adding hybrid and electric vehicles. So let's say the company uses electric vehicle remote health monitoring system, which collects data from all vehicles to the service center. The data may include variables such as oil level, tire pressure, etc. And with addition of the hybrid and electric vehicles, some new data variables need to be added: state of charge of the battery and the cell voltages. Xtypes allow adding publishers with new variables to their data structure on the existing topic without upgrading publishers on the existing vehicles. Let's now take a brief look at the ideal mechanism which makes Xtypes possible: mechanism of annotations. Some existing annotations include topic and key. Topic marks a data type that can be used as a topics type, whereas key annotation identifies a field that is used as a key for this topic type. With Xtypes, some new annotations introduced are final, appendable, mutable, and try-construct. And with that, I'm handing the presentation over to Fred Hornsey, who will describe how some of these annotations are used to describe extensibility.
Thanks, Mike. So, as Mike was saying, because types can be different in Xtypes, we have to define a way how they can be different. And we do these through what's called the extensibility annotations. The first one is appendable. In our vehicle health struct that Mike mentioned before. We have the older vehicle health that you could think of already being used in the existing gas and diesel vehicles of the rental fleet. And because the default is appendable, and this means that we can add fields to the end, and that is compatible with the existing IDL. The existing IDL will just ignore the additional fields. And here, we've explicitly marked it as appendable, but appendable is the default, so you don't really have to. It's important to note that when you add fields to appendable, they can't be put in the middle. And also existing fields can't be renamed, removed, or reordered without breaking compatibility. So yeah. Another type of extensibility, one that's more fluid, is mutable. Mutable is more fluid because behind the scenes, all the fields of the union or struct, in addition to having their member name, also have an integer ID. These IDs allow them to appear in any order, and they also allow them to be skipped or excluded by the writer whenever it doesn't know what that ID means, depending on the circumstances. We'll cover more about IDs a little later, but for now we will use auto ID hash, which generates the IDs based on the name of the member. Important thing to know is that if you want to mark things as mutable, you will have to do it beforehand before you can mutate them. So in this case, we just add the auto ID hash and the mutable annotation to our vehicle health. And then later, when we already mentioned EVs get added to the fleet, we can add these fields to the struct in the same way as appendable. One of the main differences between this and appendable is that it's possible for values that are left as their default values to be omitted when we send this message, and they will be reconstructed with their default messages on the other side. So if you had a large amount of default data, this would allow messages to be smaller. So another benefit about mutable is that if at some point in the future, all the gasoline and diesel vehicles were removed from the fleet, we could remove oil level, which is only applicable to internal combustion engine vehicles, altogether. And the benefit of mutable is we don't have to modify the existing IDL in the existing EVs. It's important to note that key fields cannot be modified like this. If you remove or modify a key field to a significant extent, it will result in the types being incompatible. And this also goes for appendable. You can't add a new key to a appendable struct, or else it will result in the type being incompatible. So that was for structs. Unions can be also modified in similar ways. Here we're just going to go over a basic appendable example where, say, we had some details about the vehicle that we also wanted to publish, odometer, location from a GPS, for example. And we wanted to add a new piece of information, we could do that. In this case, for EVs, we could say what kind of charger is it hooked up to, which might be important because it says how long that vehicle is going to take to charge. And it could also be important for helping diagnosing problems with the electric vehicle. So just to go over everything again, in Xtypes, structs and unions can differ from one participant to another while still remaining compatible with each other. And how they can differ depends on these extensibility annotations, which are appendable, which is the default, mutable, or final. And final, I did not cover, but it forces you to keep that IDL compatible the same, and that can be useful in situations where you want to communicate with non-Xtypes DDS, or if you want to really enforce that from a schema perspective. And with that, I think I will hand this over to Clayton Calabrese, who will talk about track construct.
Thank you, Fred. As Fred said, I'm here to talk about track construct. And so track construct is an annotation that defines how a reader recovers from an object construction failure. And that will in essence happen when you have two different but assignable types communicating with each other. So there are three different values for this annotation: discard, use default, and trim. And this annotation goes on the members of a type, unlike the extensibility annotation, which will go on the type itself. And if a member exists in the reader and the writer, and there is no try construct annotation, discard behavior is implied, meaning if you don't put the annotation there, it'll be handled as a discard. If a member is added to a reader, but that type or that member doesn't exist in the writer, then it will get the default value for that type. If a member exists in the writer that does not exist in the reader, then that member is ignored for try construct. And only the reader's try construct annotation matters. Try construct happens upon receiving samples from a writer, and so logically there's no use for try construct on a writer. So for each of the three values for this annotation, I've come up with a little story or scenario to talk about when you would want to use these. And so for discard, your rental company adds a gas pump, which will automatically select the fuel type for the car that is nearby the pump. And this is done using an enum, which the car's writer will send to the gas pump reader what fuel type it is. But as the earlier story suggested, we have added electric vehicles to our fleet, which would have no use for this gas pump. And so the enum has expanded to have electric in addition to diesel, premium, and standard. And so we have added the discard annotation to our fuel type for the gas pump. And what this will do is if the gas pump receives the electric value for the fuel type enum, it will throw away the sample and just not handle it, therefore preventing the user from selecting a gas type for that. And so when would you want to utilize discard? So discard is similar to the idea of a key, where if a member is absolutely necessary for a sample to be understood, if your code requires a certain part of a type or a certain member of a type, then discard is fitting for that because you absolutely need it to be understood. Additionally, if a member cannot be abbreviated or replaced without loss of information, then discard's a good idea for that member. So with use default, we have a similar scenario with the gas pump, except you don't like the idea of just throwing away samples. You want to do something with those samples. And so you've come up with the idea of, well, we'll just flash our advertisement on the display of this gas pump if we receive something that is not one of the 3 fuel types that the gas pump distributes. And so, like before, car technology improves and you add electric vehicles to your fleet. And so you've prepared for this by adding the first enum value, which would be the default, to be default. And this will be used when you receive an unknown enum value. And so in this scenario, an electric vehicle drives up and communicates with the gas pump electric, but this will go to the default value because it's an unknown value, and you will have your code handle that default value in the sample to flash your advertisement on the screen. The default values for various members are defined in the Xtype specification, but it generally corresponds to the 0 or empty value for a type. And then you would want to use default when not all writers will have all members the reader expects. So when you're supporting legacy devices, that might not produce all the information a new device does. And so for trim, we have a little different story. You have a system set up that periodically receives samples from each of the vehicle in your fleet and then logs that sample into a database. And then as your business has grown, the amount of data and samples you've collected over time has increased. You've added new electric vehicles to your fleet, you're going to have more samples, and you're concerned about, well, we're storing maybe too much data. And so you can use trim to shorten and save space on these samples that you're storing. You've decided that each sample has make and model, and that maybe you can shorten the model name and get away with it because companies typically don't name their cars very similarly. And so you want to shorten the model to just 5 characters. So when a vehicle sends your database reader a sample containing the make Toyota and the model name Corolla, your database reader will receive this sample, but Corolla is longer than 5 characters, so it will be shortened to just Corolla, and then the sample will be accepted. And so you will now have the smaller sample put into your database, saving some space. Trim only applies to bounded strings and bounded sequences, basically the stuff that you can shorten without losing critical information. And trim is when you want to reduce the size of received samples or when data precision is unimportant. So in this case, we've decided that 5 is all we need to uniquely identify the model of a car. And so we don't care about the data precision beyond those 5 characters. And so just an advanced overview of try-construct to give an idea of where this could go. Try-construct only occurs in object construction failures, so it will really only be activated on bounded sequences, bounded strings, enumerated types, and then types with those 3 things nested in them. So that would include structs, unions, arrays, sequences. Discard takes precedence over trim and use default. So if a discard occurs at the same level as a trim and use default, those will essentially be replaced with the discard. And then similarly, but not the same, if a discard happens at a lower level, it will, at the next level up, be seen as an object construction failure and can be recovered with a use default, whereas use default and trim are seen as normal or accepted samples, and so those will not be seen as an object construction failure at the level above. And with that, I'm going to pass it off to Sundin to talk about some advanced stuff within Xtypes.
Thank you, Clayton. Okay, so in this section, I am going to talk about some interesting use case of Xtype. So a common use case for a DDS application is a need to rename a member in a data type. So for example, in an old data type, the vehicle use a field name vehicle identification number as a key field, and later in a newer DDS application, the application changed the name of the field to identity. So by default, DDS Xtype doesn't support compatibility when we change the name of a member. But but in OpenDDS Xtype, we support this feature by doing two things. The first thing is we need to explicitly assign the member ID of the member that we want to change its name using ID or hash ID annotations. So for example, the um, the the member that we want to change name is hash ID number 1 in this example. And the second thing we need to do is to set the QoS of the reader side of the application so that it ignores the member names when it doing the compatibility check between the older type and the newer type. And we note that this feature hasn't been implemented in the 3.16 version of OpenDDS, but we will be adding this very soon to the to OpenDDS. The second interesting use case of Xtype is providing the compatibility with the non-Xtype system. So to obtain that, we can set the on the Xtype enable application, we set the extensibility of the data type to either final or appendable, and we use the data representation type of XCDR1 on the Xtype system, so that the data on the Xtype system is encoded in a similar way to that of the non-Xtype system. And one caveat is that the IDL of both non-Xtype and Xtype system need to be identical. Otherwise, they won't be able to communicate properly. More detail on this topic we provide in the OpenDDS developer guides. So you can take a look at it for more details. So behind the scenes, there are several components that we implemented in OpenDDS in order to support Xtype. The first important components is type identifier and type object. Type identifier and type object are an alternative to the IDLs, which describe the data type of the communicating peers, and they are data structure, and so they can be operated on and can be manipulated to perform the type compatibility checks between between the peers of the Xtype system. The second important component of the Xtype system is type lookup service. It is an internal service that provide an ability to exchange type object between peers. So if you have a local Xtype application and you want to learn about the remote Xtype type, then the underlying system will send a type lookup request for the remote type and get the a reply for the type object of the remote type. And type lookup service provide is incorporated into the discovery process so that the local application can learn about the remote data type and perform the compatibility check between local type and remote type. And we also provide security for type lookup service. And this is enabled when the security is enabled in discovery. The third important component is data representations. So Xtype provide various type of encoding format, and users can choose which encoding format they want to use by setting the extensibility kind of their data type and the encoding versions they want to use, either XCDR1 or XCDR2. So that provide a lot of flexibility in the encoding format the user want to use for their application. With that, I will hand over to Adam for the next section.
Thank you very much. And thanks to everyone on our team who helped with putting all these features together and presenting it today. So to wrap up, we want to look at a few key points here. So what else is in Xtypes? So not every single thing in the Xtype specification is currently in OpenDDS, but we hope to add more in the near future, including the dynamic types API. So dynamic types addresses the problem where you'd like to have a participant application that communicates on the DDS domain without having code generated from IDL, right? Very similar to reflection systems that are in general purpose programming languages. Also support for additional annotations that OpenDDS doesn't yet have, things like assigning custom values to be the defaults of members of structs, and the ability to have optional fields. There are also extensions from the IDL specification itself in IDL version 4, and not all of those have made their way into OpenDDS yet. One of the key ones there is struct inheritance, and that is something that we could also add to OpenDDS in the future. So of course, we welcome your involvement and participation in the OpenDDS project, whether that's through GitHub issues, through contributing code, and even through sponsorship. So some next steps to consider, please go ahead and download OpenDDS version 3.16 or newer. 3.16 is what's available today, but if you're watching this on a recording, the latest release is what we'd suggest. And of course, that's always available at the GitHub repository page or at opendds.org. And our developer's guide PDF is a free download of roughly 230 or so pages at this point of documentation on using OpenDDS. If you'd like to get started quickly setting up your own programs that make use of OpenDDS, we do offer online training, and our upcoming training event is March 3rd and 4th, and you can register for that at the link below, or if you're watching this on a recording, we do offer those pretty regularly, so check in with our website and you'll see when we're next offering the introductory class. The Introduction to OpenDDS programming class takes you through setting up an application, including its IDL, and publishing and subscribing parts in either C++ or Java. And also consider how can our group, how can OCI help you be successful with OpenDDS? So we offer custom training, many different training modules, more extensive than the introduction training that I was just talking about. We offer architecture and design consulting. We'll work on porting, extending, or integrating OpenDDS. We do performance and scalability analysis and any number of research and development sorts of projects. And we also offer ad hoc support. So please see the contact us details on the next page or visit the link below for all of those details. And so, Nikki, if we have any questions, I think now would be a good time for those.
We do have one question, so I'll read that one out loud. And while we're answering this one, we invite the audience to type your questions into the chat or ask it in the Q&A. Now is the time. So the first question that we have is there a roadmap for optional annotation to be implemented?
Right. So that's on these, additional annotations. So OpenDDS is a project that evolves like a lot of open source projects according to the needs of various stakeholders. So if it's important to you, we can work with you to figure out how to get that ready on your particular timeline. I don't have any other details to share now about kind of when these additional features will happen, since there's so many factors that determine that.
Okay, makes sense. That's the only question I see right now. Oh wait, no, we have another one. Where is the default value for a type member specified? Does it require an additional annotation?
Yes, so that's here under the additional annotations on the slide. So the Xtype specification describes how you can define specific default values on a member by member basis. And so that's not in OpenDDS yet, but another one of those things that will be added in the future.
Got it. Well, stay tuned for that, everyone. I think that's all the questions we have. So this recording will be made available sometime in the next 48 hours, and we'll share the slide deck as well. We encourage you to take a look at that and ask any follow-up questions that you may come up with between now and then. Thanks for joining, everyone.
Thank you.